Welcome to This Explainer. Today, we're unlocking a massive productivity multiplier. I'm going to give you the ultimate cheat code to solve front-end and API bugs before you even think about writing a support ticket or, digging through thousands of lines of code. If you work with web apps, this masterclass is literally going to save you countless hours of frustration. Let's get into it. We've all been there, right? You open your issue tracker and staring right back at you is this incredibly vague, unhelpful bug report. Payment fails on submit. Please fix. It's exactly the kind of report that usually leads to hours of wasted code spelunking, throwing in random console logs, and just kind of blindly guessing where the problem might be hiding in the front-end code. Okay, let's dive into this. Because before you write a single ticket or change a single line of JavaScript, you really have to ask yourself, did you check the Network tab? Seriously, the Chrome DevTools Network tab is your ultimate, undeniable source of truth. It tracks the exact communication happening between your app and the server. It intercepts the raw data before the UI can hide it or just swallow the error completely.
So let's kick things off with Level 1, the ultimate bug cheat code.
Think of this explainer like a video game where we're gearing up with the ultimate cheat code to defeat those terrible bug reports. The very first thing we need to do? Upgrade our mindset. We absolutely have to stop guessing with console.log. Relying on console logs means you're only seeing what the developer actively chose to print out. DevTools, on the other hand, it gives you direct observation of the application at multiple technical levels. It captures every single HTTP request and response in real time, whether your code expected it to happen or not. Moving right along to Level 2, the Network tab layout. To actually use this cheat code effectively, we really need to understand our developer's HUD, or heads-up display. There are 4 main zones in that classic dark theme DevTools layout, going from top to bottom. First up, the toolbar at the very top. This is where you can toggle things like preserve log, so you don't lose all your data on a page reload, or disable cache, to make absolutely sure you're getting fresh responses. Right below that is the filter bar. Think of this as your precision targeting system for finding specific endpoints. Then we get to the main event, the request list, where you check the status and details of every single network call. And finally, the waterfall column over on the right, which lets you read the exact timing of each request. Now, a massive, absolutely crucial part of mastering this interface is knowing what not to look at. A modern web page triggers hundreds of network calls, right? It creates a ton of visual noise. But when you're debugging an application state or an API bug, you can confidently ignore things like CSS and font files, image rendering logs, third-party tracking scripts, extension URLs, and unrelated data URLs. Seriously, filtering all of that out is your first big step to total clarity. All right, let's jump into Level 3, Core Debugging Techniques. Now that we've cleared away all that noise, it's time to learn the core combos that make finding bugs just incredibly fast. So, the crucial point here is mastering the filter bar. By simply opening the filter bar and toggling the fetch/XHR button, you instantly strip away all that visual noise we just talked about. XHR and fetch, those are the mechanisms your JavaScript uses to talk to your APIs. So with literally one click, you reduce hundreds of requests down to just the handful of actual data operations you care about. You can even filter it down further by typing specific commands, like isolating just your post requests. It's a game changer. When you click on one of those isolated requests, a side panel opens up. And here, you really need to understand the difference between the Headers tab and the Payload tab. Think of the headers as the envelope. It contains all the metadata, the status code telling you if it actually succeeded, your auth tokens, your cookies, the whole shebang. The Payload and Response tabs, those are the letter inside the envelope. That's where you inspect the actual JSON data being sent over to the server or the exact data coming back. Rule of thumb, if a session is expired, look at the envelope. If the data itself is malformed, read the letter. Let's move over and see how this builds in the Waterfall tab. This feature is super cool because it breaks down exactly where a request is spending its time. Is the request stuck waiting for an available connection? Is it getting delayed by SSL handshakes? Or is there a massive gap at TTFB, time to first byte, which usually means your database or backend server is really struggling to process the request? The waterfall basically makes performance bottlenecks instantly visible. And now for the main event, Level 4, Boss Fight, Payment Failed. All right, it's time to ramp up the energy and apply everything we've just learned. Paint this picture in your mind. We're on a public demo sandbox, something like saucedemo.com. We've got Chrome DevTools open on the right side of our screen, dark theme engaged, obviously. We fill out the payment form, we hit submit, and the UI just spins. and then it silently fails. There's no error message on the screen. Nothing. Well, time to pull out our cheat code. We jump straight into the Network tab. First thing we do, we click that fetch/XHR filter. Instantly, amidst the total silence of the UI, DevTools practically screams the truth at us. We spot this bright red failing request hitting the API payment initiate endpoint. So we click it, we inspect the headers tab, and bam, there's the smoking gun. The authorization token is completely missing from the request header. And just look at the status code on that red request. 401 unauthorized. This specific HTTP status code means the server is explicitly rejecting the request because it simply doesn't recognize the user. Because the auth token was missing or expired, the backend stepped in and blocked the payment. The front-end UI, it just didn't know how to handle that error properly, which is what caused that silent spinning. So we found the bug, but we're not quite done yet. Now, what's really interesting here is the ultimate mic drop feature of Chrome DevTools. Right-click that failing 401 request in your list, hover over the Copy menu, and select Copy as CURL. This magic little trick extracts an exact, executable replay of the request exactly as your browser sent it. It captures the exact headers, the cookies, the payload, everything. With that command copied to your clipboard, you can paste it directly into your computer's terminal. And when you hit Enter, you will safely reproduce that exact 401 error entirely outside of the browser. Guys, this is massive. It unequivocally proves that the issue is with the API constraints or the authentication state. It completely rolls out a bug in the front-end UI rendering code. You've isolated the problem perfectly. Let's just take a second to look at the incredible transformation in our workflow here. The old way, where we started this whole explainer, left us with a frustrating, vague complaint that just said, payment is broken. But the Masterclass way, and empowers us. We can now provide a highly precise ticket that hands a backend developer the exact failing endpoint, the exact status code, and an executable command to recreate the issue on their own machine instantly. Just look at this beautifully precise mic drop developer ticket we just generated. Endpoint API payment initiate returns 401. Session token expires before submit. Curl command attached to reproduce. Wow, we diagnosed a silent, tricky bug, isolated the exact cause, and wrote the absolute perfect fix-it ticket, all in under 5 minutes, without reading a single line of front-end code. That, my friends, is the power of the cheat code. So here's my challenge to you. The next time a bug report lands on your desk, or a UI starts behaving strangely, are you going to dive headfirst into the code and start blindly guessing? Or are you going to open up Chrome DevTools, click on the Network tab, and let the data tell you exactly what's wrong? Open DevTools on your current project right now and see what you find. Thanks for joining this explainer, and hey, happy debugging!